we can also find the average rate of change of any given function. For a linear function, the rate of change is constant. So that's what you guys did in Algebra 1. That's what we're used to finding. It's constant and it's indicated by the slope. So even for a nonlinear function, you can find the average rate of change over any interval by finding the slope of the segment that connects the points on the graph determined by the endpoints of the interval. So given you have an interval from x1 to x2, the average rate of change can be found using this formula here. So what happens is it's the same as when you guys used to find slope. You used to do change in y over change in x. You were just given 2 point values, like y is 7 or y is 9. Well, now you are going to calculate the function value. So the function equals what at x value 2 minus what does the function value equal at x1. And then you just divide that by the two x values that you just used, the difference of the two, x2 minus x1. So if you're given the actual graph, you can sort of look at it. If not, we'll use that function or that equation, that formula, to find the average rate of change. So for number 5, it says find the slope of the line segment that connects the indicated points A and B. So A to B you have 1 over 1. So the slope would be 1. From B to C, up 1 over 2. C to D, up 1 over 4. So the rate of change is 1 over 4. And D to E, up 1 over 1, 2, 3, 4, 5, 6, 7, 8. So the slope would equal 1, or the rate of change would equal 1 over 8. So if you're given a graph, sometimes you can just look at it. But if you're not given a graph, you're just given the function, and like we could have plugged that in. It's telling us that this is the equation we used to graph that or get that graph. But if you're just given the equation, all we do is plug it in. So that's what it's asking us to do for number 6, and then it wants us to sort of explain what happens or what does this rate of change mean for the graph. So we'll explain that afterwards. So this is our equation that we're using. F of x equals 2 to the power of x minus 2 plus 1. So it's exponential. And it wants us to find the average rate of change over the given intervals, negative 2, 0, 4, 6, and 6, 8. So this is our x1 and 2. It's not an ordered pair, it's a range from negative 2 to 0. So what we do is plug it into the function and find the difference of each given x value. So let's plug in. I'm just going to write my function here real quick. 2 to the power of x minus 2 plus 1. Okay, so let's plug in x sub 2 or x2 first. So 2 to the 0 minus 2 plus 1 minus, plug in x1. So 2 to the negative 2 minus 2 plus 1. And then we just divide that by the actual x values subtracted from themselves. So 0 minus negative 2. All right, so 2 to the negative second is 1/4. Plus 1 is 1 1/4. Minus 2 to the negative 4th is 1/16. Plus 1 is 1 1/16. Over 2. So just keep simplifying it. So 1 1/4 minus 1 1/16. you can make that 16ths if you wanted to, and then subtract them and get 3/16. You guys could do these as a decimal if you wanted to. I would not have a problem with that. That would be fine. And then 3/16 divided by 2 is going to be 3/32. So that's your rate of change for this first interval. If you guys did decimals, it should have been about 0.0938. So I'm okay with you guys using decimals. So there's nothing wrong with that. As long as you're showing your work, that's fine. And then 4 to 6. So same thing again, just plug it right into that equation, into that function. So 2 to the power of 4 minus 2 plus 1 minus 2 to the power of, and I did my x1 first. So that should be 6 minus 2. Okay, then 2 to the power of 4 minus 2 plus 1 over 6 minus 4. So 2 to the 6 minus 2 is 2 to the 4th, which is 16 plus 1 is 17. Minus 4 minus 2 is 2. 2 squared is 4 plus 1 is 5. And then 6 minus 4 is 2. So 17 minus 5 is 12 over 2, which is 6. So the rate of change for this interval is 6. And then the last interval is from 6 to 8. So again, just plug it right in. So 2 to the 8 minus 2 plus 1 minus, plug it in your second x value or your first x value, 2 to the 6 minus 2 plus 1 over 8 minus 6. So 8 minus 2 is 6, 2 to the 2nd, or 2 to the 8, 2 to the 6th, yikes. 2 to the 6th is 64, plus 1 is 65, minus 6 minus 2 is 4, 2 to the 4th is 16, plus 1 is 17 over 2. So we get 65 minus 18. So we get 48 over 2. So 24 is our rate of change for this section, or this interval. So we found our rate of change over the intervals it asked us to, and it says what happens to the average rate of change as x increases. What does this mean for the graph of the function f of x? So if you notice, it starts out as a really small rate of change or small slope. We've got 3 over 30 seconds. That's closer to 0 even than 1, but it's smaller than 1. And then it jumps to 6, and then it jumps to 24. So as far as increasing, it is increasing because it's getting larger, obviously, but it's increasing pretty quickly. So it's not going to be a steady rate of change, and you guys should know that this is actually an exponential graph. So what happens is this is actually starting to increase pretty quickly and gets pretty steep in a short amount of time. So we're going to say as x is increasing, y is increasing rapidly or quickly. So it is a positive function or an increasing function. for all intervals. We'll say that. And we're really just looking for any kind of description. If it matches, there's nothing like you have to make sure you include. Just kind of what you notice after you find the rate of change.